Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to show you how to calculate a given amount of reactant from a given amount of product using a series of reactions and stoichiometry. So let's get into this. So the problem here, they're asking us, they're telling us that NaBr, sodium bromide, can be prepared through a set of reactions. We got these three reactions here. And they want to know how much iron in kilograms is consumed in the first step here. So we want to know how much iron is needed in the first step in order to produce 3.50 times 10 to the third, or 3,500 kilograms of NaBr in the third step. So we forgot the kilograms here. So they're giving us kilograms of NaBr. Okay, so first thing we need to do is we need to balance the equations, because in order to use stoichiometry, you have to have balanced equations. So how do I know that this is a stoichiometry problem? Because stoichiometry requires that you go from one substance to a different substance using a balanced equation. And so the fact that they're asking me about iron and giving me a certain amount of NaBr, which is a different substance, I need to use stoichiometry to do that. And the only way that you can convert from one substance to another is through the mole ratio of the balanced equation, or some mole ratio that you can find. Okay, so in this problem, we're going to be using mole ratios to convert from one substance to another. So we need to balance the equations first. So here we have Fe. So we always start with the metals first. Balance the metals first and then the nonmetals. So there's some rules of thumb that you want to follow. So metals before nonmetals. If you have only nonmetals left, then you're going to balance all of the nonmetals before hydrogen and oxygen, right? Usually you leave hydrogen and oxygen for last. And then between those two, usually oxygen is last. But another rule of thumb you want to keep in mind is that if you have an element that's by itself, you're going to save that one for last, usually. Okay, so let's take a look. Here we have metal, iron, so we're going to balance that. We have one on each side, so that's balanced. And then now the nonmetals, bromine, we have two bromine here and two bromine here. So that's already balanced. So we can go to the next one. Okay, let's look at the iron, the metal first. So metals before nonmetals. We have one iron on this side, and we have three irons on this side. So we need 3 on that side. So we're going to put a coefficient 3. So now we have three irons on both sides. Now we can go to the bromine. So we have 3 times 2 is 6, plus 2 is 8. So we have 8 bromines on this side, and we have 1 times 8 is 8. So we got 8 bromines on this side. So now we have a balanced equation. And last but not least, we have this equation to balance. So again, metals before nonmetals. So iron and sodium are metals, so we'll balance those first. So here I have 3 irons, and here I have 3 irons, so that's balanced. Here I have sodium. I have 2 sodiums here, but I only have 1 sodium there. So I'm going to put a 2 coefficient there. So now I have 2 sodiums. So that's balanced. Okay, next we're going to do the nonmetals. So notice I have oxygen, I have carbon, and I have bromine. I'm going to balance the bromine and carbon first. I'm going to leave oxygen for last. Usually you leave oxygen for last if there's no element by itself, then usually the rule of thumb is you leave hydrogen and oxygen for last, but in this case we don't have hydrogen, so it's just oxygen. So we'll leave oxygen for later. Here I have 8 bromine, but here I only have 2 bromine, right? So I need to get 8 over here. So let's change this to an 8. So now I have 8 bromine on both sides. But notice the sodium is unbalanced. So I got to go back to the sodium and balance sodium. So I have 2 sodium on this side. So what times 2 gives me 8? 4. So I got 4 now. So 4 times 2 gives me 8. And then 8 times 1 gives me 8. So now my sodiums are balanced. My irons are balanced. My bromines are balanced. So now let's go to carbon. So here I have 4 times 1 gives me 4 carbons. On this side, I only have 1 carbon. So I'm going to have to put a coefficient of a 2 on this side. I'm sorry, a coefficient of a 4 on this side. So now I have 4 carbons and I have 4 carbons. Okay, carbons are balanced. So everything is balanced except for oxygens. Let's see if they're already balanced. So here I have 4 times 3 is 12. So I have 12 total on this side. Here I have 4 times 2 is 8. Plus 1 times 4 is 4. Add those together, I got 12. So now they're both balanced. So I have same number of oxygens on both sides. So all of the equations are now balanced. So now I can use the equations to do, oops. Sorry about that. Now I can do the coefficients. I can do the conversions using the mole ratios. Okay, so they give me 3.50 times 10 to the third kilograms of NaBr. So we're going to start with that. And so I'm going to start with 3.50 times 10 to the third kilograms of NaBr. And my goal is to get to kilograms of the iron. Okay, so I got kilograms of NaBr. I got to get to the amount of iron in kilograms. So there's 3 stages to a stoichiometry problem. The first stage is to convert the given unit you have to moles. Why? Because the only way that you're going to convert from one substance to a different substance is the mole ratio. You can't use a mole ratio unless you have moles. So that's your first stage. The first part of the stoichiometry problem is to get your unit to moles. So let's do that. So we need to get the moles. If I had grams, if I could use the molar mass in grams to convert to moles, that would be nice, but I need grams. So the first thing I need to do is convert kilograms to grams. So I know that 1 kilogram is equal to 1,000 grams because kilo is 1,000. So I'm going to put 1 kilogram of NaBr on the bottom and 10 to the third or 1,000 grams of NaBr on top. Kilograms cancel out. Now I have grams on top. Now I can use the molar mass of NaBr to convert to moles. Anytime you have grams and you want to convert to moles, that's going to be used the molar mass. So you calculate the molar mass of NaBr, and that's going to be 102,894. So 192, let me double check that again. 102,894. So 102.894 grams of NaBr. And then that's going to be on the bottom because I have grams of NaBr on top. I want that to cancel, so I'm going to put it on the bottom here. And then I'm going to put 1 mole of NaBr on top. And let me double check 894. That is correct. So now the grams of NaBr are going to cancel out. Now I have moles. Now I'm done with the first part of my stoichiometry problem. The second part is now to convert moles of the given substance to moles of the desired substance using the mole ratios. Now, in this case, we have 3 equations. We would like to have a mole ratio between NaBr and Fe, but we don't have Fe in this equation. So we're going to have to use multiple mole ratios, conversion factors, to go from moles of NaBr to moles of iron, right? So I know that Fe3Br8 is common here and here, so I can do a mole ratio to convert between moles of NaBr and moles of Fe3Br8, and then I could use the mole ratio between Fe3Br8 here and the FeBr2 here, right? So let's go ahead and do this. So we're going to do the mole ratio between NaBr and Fe3Br8. That's an 8:1 mole ratio. So I'm going to put on the bottom 8 moles of NaBr and 1 mole on top of Fe3Br8. So now the moles of NaBr cancel out. Now I have moles of Fe3Br8. Now I can use the mole ratio between Fe3Br8 and FeBr2. And it's a 1:3 mole ratio. So let's go ahead and set that up. So now I have moles of Fe3Br8 on top. I'm going to have 1 mole of Fe3Br8 on the bottom. Fe3Br8. And on top, I'm going to have 3 moles of FeBr2. So 3 moles FeBr2. FeBr2. So now the moles of Fe3Br8 cancel out. Now I have moles of FeBr2 on top. Now I can go to the first equation where I have a relationship between FeBr2 and iron, right? So now I can do a mole ratio and get to iron using FeBr2 and iron. So here it's a 1:1 mole ratio. So now I'm going to continue down here since I don't have enough room. So 1 mole of FeBr2 on the bottom and 1 mole of Fe on top. So the moles of FeBr2 cancel out. Now I have moles of iron. They want kilograms of iron. So now I need to get to mass. So now I am done with stage 2, right? So I've used the mole ratios to get to iron. Now stage 3. Stage 3 is to convert moles to whatever the desired unit is. In this case, kilograms, which is mass. So since I got to go from moles to mass, I got to use the molar mass of iron. So I look up the molar mass of iron, and I get 55.845. So 55. So on the top, I have 55.845. Let me double check that. 55.845. That is correct. This is going to be grams of the iron. And on the bottom is going to be 1 mole of the iron. So moles of iron cancel out. Now I have grams, but I don't want grams. I want kilograms. So I got to keep going. So it's just one more step because I know that 1 kilogram is equal to 1,000 grams. So I got grams here. I'm going to put 10 to the third grams of Fe. And on the top, I'm going to put 1 kilogram of Fe. So now grams cancels out. And I'm done. I have kilograms of iron. That's what they're asking me for. So I am done with the conversion factors. So now all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 508.82, 508.82 kilograms of iron. Now, sig figs. We got to worry about our sig figs. So if you are worried about sig figs, then remember the rule. Your answer, the rule for multiplying and dividing says that your answer should have the same number of significant figures as the measurement with the least number of sig figs. So ignoring the exact relationships. So let's go through this. So here, excuse me, here we have 3 sig figs. Here, this is exact, so we can ignore that. Here we have 6 sig figs. This mole ratio is exact. This mole ratio is exact. This mole ratio is exact. Here we have 5 sig figs. And here we have exact relationship. So the least number of sig figs is 3. So that means that our answer is limited to 3 sig figs. So that means we count 1, 2, 3. We cut it off there. Here we have an 8, which means that we have to round this to a 9. 509 kilograms of Fe. And that, ladies and gentlemen, is your answer. I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button over here somewhere or there, right? Support the channel, subscribe to my channel, hit that notification bell, and when you do, make sure you click all, and when you click all, after that, you're going to put a comment down below in the comment section. Yes, you are. And what you're going to do is you're going to tell me what you think. Ask me questions. I would love to hear from you. If you have a question or a problem that you need help with, or if you have a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me, and have a great day.